The F block, or F subshell, is a peculiar part of the periodic table that gets very little attention, but is highly respected. It contains the elements on the periodic table between atomic numbers 57 to 70 and 89 to 102, which are transition metals. Transition refers to an element's ability to lose and gain electrons. Most elements in the periodic table can do this, but not as readily as the transition metals. Understand that all elements in the universe, as we know them, are listed on the periodic table according to a number of different characteristics, in particular, atomic mass or size. The top left of the periodic table begins with the smallest elements, hydrogen, lithium, and beryllium. The bottom right ends with the largest elements, xenon, astatine, and radon. The size or mass is determined by the atomic number located above the element symbol. Additionally, the periodic table is sectioned into blocks, S, P, D, and F. These blocks, or subshells, are part of the electron organization within the atom. Where do these terms, shell, subshell, and orbital, come from? Recall that electrons, protons, and neutrons are subatomic particles that come together to form the atom. To better imagine atomic structure, picture the solar system in which we live. The sun is the nucleus of this system, just as protons and neutrons are the nucleus of the atom. The planets rotate and revolve around the sun at various speeds and trajectories, depending on their mass, distance from each other, and distance from the sun. Similar forces are at work on a much, much smaller scale when describing electrons that surround the atomic nucleus. Theoretically, as first calculated by the physicist Niels Bohr, electrons move in orbits or orbitals, a term physicists prefer rather than subshells. Each orbital occupies different energy levels, or shells that number from 1 to 7. Electron orbital structure is calculated using the probability of them being in one place or another around the nucleus, dependent upon the mass of the atom, distance of the electrons from the nucleus, velocity, and energy. Orbital S can contain up to 2 electrons, P can contain up to 6 electrons, D can contain up to 10 electrons, and F can contain up to 14 electrons. Here are the structures for each orbital. Keep in mind that the F block of the periodic table refers to the F orbital, green, which is part of the order and energy level of electrons that surround the atomic nucleus of these transition metals. The F block of the periodic table contains 2 rows called series. Each series has its own name and properties. Atomic numbers 58 through 70 are the elements of the lanthanide series, transition metals. These naturally occurring elements are usually found clustered together and are very rare. Thus, these are referred to as rare earth elements. Their atomic structures are similar to each other, and each contain enough electrons of sufficient energy to occupy the F orbital of the 4th shell. Of course, differing numbers of electrons in the 4F shell give each element their unique properties. The elements with atomic numbers 89 through 102 are transition metals of the actinide series. There is one element that characterizes all the other elements in this series you may be familiar with, plutonium. All of the elements in this series are radioactive, and all but 3 are man-made. The atomic structures of these elements also contain electrons with sufficient energy to also occupy the F orbital, but in the 5th shell in this series. So when you look at a periodic table, understand that elements are listed by sizes, from left to right and top to bottom. Those elements in the center rows separated from the table are transition metals of the rare earth, lanthanide, and synthetic radioactive, actinide elements called the F block. Electron locations within orbitals and shells are determined by the probability of their distribution around the nucleus based on mass, distance, velocity, and energy. The highest energy electrons occupy the F orbital, placing these elements in what is referred to as the F block of the periodic table.